Okay, for the last session, we explained about what is the um, NTU method for finding the heat transfer rate for heat exchanger, right? So for heat exchanger, we have studied three equations, right? First one is related to LMTD flow, that is Q equal to UA theta M. Okay, the LMTD can be found by using two conditions, that is counter flow and parallel flow, that is same equation, but theta 1 and theta 2 different. Okay, for second condition, we have studied a particular equation Q equal to UAF theta M. UAF theta M arrives when we are using multiple shell, multiple pass, okay, or coarse flow, for a coarse flow. We are using the particular equation of Q equal to UAF theta M. F can be found out by using graph, plotting graph by using P value and R value, capacity ratio and temperature ratio. I have already done. For the last topic, for the last session, we explained about a particular equation called NTU method. So what is the NTU method? Using effectiveness. Okay. So effectiveness, we had derived equation for a parallel flow and counter flow here. And NTU, we write NTU as NTU equal to UA by C minimum. UA by C minimum. C minimum is the minimum value of CC or CH. Okay, for cold fluid C value or hot fluid CH value, which is the minimum value, we are taking it as a C minimum. And a C minimum by U into A into a C minimum. U is equal to overall data as a coefficient, A is data, and C minimum is the minimum value of CH or CC. Okay, so we had derived two equations for effectiveness, that is for parallel and for counter. Okay, so today for this section, I'm explaining about how we can do it, something, how we can solve a problem by using NTU method. For the previous session, I have explained a problem relating to the f value af theta m by using graph, by using a data book, right? So same method we are doing a problem. We are solving a problem of NTU method by using the same type of graph in the data book. So please write down the problem. Thereafter, I will explain how we can find out the value of NTU by using the graph. Okay. So please write down the problem relating to NTU method. How we can find the value of NTU or effectiveness by using graph, or how we can solve a problem. If a question is asked like that, find the particular rate of heat transfer or particular rate of area or anything like that by using NTU method. Okay, by using NTU method, how we can solve the problem by using NTU method, or how we can take the value of NTU or effectiveness by using graph in data book. Okay, so please alert me if any connection problem is there. Okay, in your WhatsApp. So please learn a problem. A counterflow heat exchanger. A counterflow heat exchanger. A counterflow heat exchanger is employed to cool. Is employed to cool 0.55 kilogram per second. 0.55 kilogram per second. 0.55 kilogram per second. In the bracket, CP value. CP equal to 2.45 kilojoule per kilogram degree Celsius. Kilojoule per kilogram degree Celsius. Employed to cool 0.5 kilogram per second of oil from 115 degrees Celsius to 115 degrees Celsius to 40 degrees Celsius, 40 degrees Celsius by the use of water. By the use of water. By the use of water. So water is used to cool the oil. Okay. The inlet and outlet temperature of cooling water. The inlet and outlet temperature of the inlet and outlet temperature of cooling water. Cooling water are 15 degree and 75 degrees Celsius are 15 degrees Celsius and 75 degrees Celsius, okay, respectively. The overall heat transfer coefficient is expected. The overall heat transfer coefficient U, is 1450 watt per meter square degree Celsius. Watt per meter square degree Celsius. 1450. Okay. Using NTU method, calculate the following. Calculate the following. So using NTU method, you want to find some particular values of the one mass flow rate of water. Mass flow rate of water. That is MW or M of water or MC. Water is used to cool. Water is using as a cooling medium. So it is MC. Okay. MC. Bracket MC. The effectiveness of heat exchanger. Effectiveness of heat exchanger. Effectiveness of heat exchanger. Okay. Third one, surface area required. Surface area required. Okay. Surface area required. The question is that a counterflow heat exchanger is used to employ to cool an oil, which means to cool an oil, which means the hot medium is the coil. We are using the water to cool the. We are using the particular type of water is used to cool the oil. So the hot medium is oil, right? Hot medium is oil. Oil is cooled by water, and inlet and outer temperature of oil and water is given, and Cp value of oil is given, and mh value of oil also given. So mc value of water and Cp value of water is not given, right? So please note a point that note if Cp of water is not given, Cp of water is not given. In the case of water problem, the case of problem involving water is not given, we can assume it as it's an important point, like that we are using the particular density of air, density of water is 1000 and density of air is 1, right? So we are assuming that we can, this is standard value of particular ratio of water and air. Okay, you must be importantly know that the particular value of something like density and capacity, like water and air. You want to be thorough. Okay, so if the Cp of water is not given, we can assume it as Cp equal to Cp of water. Cp of water is a particular standard value. So it is a constant value. You want to be by heart. It is 4.18 kilojoule per kilogram degree Celsius. Cp of water. Please mark it as important and please keep it in a box. Cp of water is 4.18 kilojoule per kilogram degree Celsius. Okay. So you want to find, first question is to find first question. So please write down the given value first. Please write down the given values first. M dot H is given. M dot H 0.55, right? Kilogram per second. Hot fluid. That is oil. MH value of oil is given. And Cp of oil is also given. Cph is equal to 2.45 kilojoule per kilogram degree Celsius. Okay. TH1 and TH2 is given. TH1 equal to 150. TH2 equal to 40. TC1 and TC2 is given. TC1 equal to 50 initially, temperature will be very low. TC2 equal to 75 degrees Celsius. Okay. Then at the U value, overall heat transfer coefficient is given as 1450 watt per meter square degree Celsius. And we are assuming the value of water, CPC of water is 4.18 kilojoule per kilogram degree Celsius. These are the values given in our problem. Okay. These are the values given in our problem. So first question is to find the value of MC, right? First question is Mass flow of water, mass flow rate of water, mass flow rate of water equal to mc, right? Mc. So we know that q equal to m dot h cph th1 minus th2 equal to m dot c cpc of tc2 minus tc1, right? It's a very important relation. We are using the particular equation in our 80% of a problem. Okay, so q equal to m dot in cph th1 minus th2 equal to m dot in cpc tc2 minus tc1. That is at a particular point the heat rejected by a hot fluid is equal to the heat absorbed by the cold fluid at the same point. Okay, so we can equate the particular values here. We can equate m dot h is given, cph is given, th1 is given, th2 is given, m dot c is unknown. You want to find out cpc is given, tc2 is given, and tc1 is given. Sorry, so the only unknown value here it is cpc. Sorry, m dot c. M dot c. That value you want to find out. The all other values are given in your problem. Okay, so please find out the value of m dot c here. So please find out the value of m dot h is equal to 0.55, right? M dot h is 0.55 kilogram per second. It is not given in kilogram per hour or kilogram minute. So you don't want to convert into particular second. It is given in a second value. So we can take the value of 0.55. Okay, 0.55 into, please use a calculator and find the value quickly. 0.55 into CPH 2.45. 2.45 into TH1 minus TH2. That is TH1 is given as 115 minus 40 equal to m dot c into CPC is 4.18 and TC2 is 15 minus 75. Okay, 75 minus 50, 75 minus 50, TC2 minus TC1. So we will get the value of m dot c directly as 0.4 kilogram per second, right? Calculate it by using calculator and you will find the value of m dot c as 0.4 kilogram per second. Okay, so the second question, effectiveness of heat exchanger, right? Effectiveness of heat exchanger, that is heat exchanger is given as, the question is given as counterflow. Okay, counterflow. So we have the equation for a counterflow equation as effectiveness equation as 1 minus exponential of minus NTU into 1 minus R and 1 minus divided by 1 minus R exponential of minus NTU into 1 minus R. Okay, this is the equation for a counterflow effectiveness, right? Equation for a counterflow effectiveness is E counter equal to 1 minus exponential of minus NTU into 1 minus R divided by 1 minus R into exponential of minus NTU into 1 minus R. So please check that. So whether we can find the value, or not. So here E counter and what is NTU? R can be found out. Okay, R can be found out. R is equal to C minimum by C max. R is C minimum by C max, right? R equal to C minimum by C max. So we can find the value directly. C minimum and CH and CC is known. So C minimum by C max can be found out. Okay. So what is NTU? U A by C minimum, right? U into A by C minimum. So A is not given in your problem. So third question is to find out the surface area, right? Third question is to find out the surface area. So we cannot find the value of E counter by using this equation. Okay, we cannot find the value of E from this equation. That is NTU. The value of NTU is unknown. That is UA by C minimum. The value of A is unknown. So first we have to find the area. Area to find the value here. So how can we find out the value of area? How can we find the value of area? Area, what is the equation of area? It is NTU equal to UA by C minimum, right? So this is the only equation to find out the area and NTU. This is the only relation we are using in a particular type of section to find out the value of area or NTU. Whether NTU is known, we can find out the value of A. If A is known, we can find the value of NTU. So this is the only relation we are adopting here. Okay. So to find the area, we need NTU. To find NTU, we need the area. Okay, so we cannot find out the value of E counter by using this equation here. Okay. We cannot find the value of a particular E counter. Effectiveness, we cannot find the equation we cannot find the value by using this equation because NTU is unknown. To find NTU, we need area. Okay, to need area, to find the area, we need NTU. Okay, so we cannot find the value of effectiveness by using that equation. Okay, the equation is the particular equation is E counter equation is this only this equation. So whether there is any equation left for find the value of effectiveness, any equation left to find the value of effectiveness. Okay, please check your notebook that we have written two equations of effectiveness from the early derivation. What was that? This is that. Okay, this is the particular equation. Check the equation, that is E equal to CH by C minimum of TH1 minus TH2. This is a general equation. We can use the particular equation in the case of parallel or counter. Okay, we can use this particular equation in the case of parallel or counter. This is a general equation. So we can use this equation to find out the effectiveness there. Okay, you can use this equation or this equation to find out the value of effectiveness there. Okay, first you want to find the value of effectiveness by using this equation, because you cannot find the value of equation. We cannot use the equation because NTU is unknown. Okay, so we can use this equation, that is first equation. We can take first equation CH into TH minus TH2 by using this equation. Which NTU is unknown. NTU is unknown. We want to find NTU. We will find the value of NTU later. But here for second question we can find out the effectiveness value, that is NTU is unknown. So E equal to CH of TH1 minus TH2, right? CH of TH1 minus TH2 all divided by C minimum of TH1 minus TC1, right? C minimum of TH1 minus TC1, right? Q by Q max. Effectiveness is Q by Q max. Q by Q max. So what is the value of C minimum here? What is the value of C minimum? So for finding the value of C minimum, first you have to find the value of CC or CH. Okay, CC or CH രണ്ടും കാണണം. എന്നിട്ട് what is the minimum value? We can take that minimum value of by comparing them both. Okay, first value of CC and CH. CC equal to m dot C CPC. Okay, find the value, and CH equal to m dot H CPH. Find the value of CC and CH. Find the value of CC and CH. CC and CH. That is m dot C means 0.4 into 4.18. Okay, and m dot H CPH is 0.55 into 0.45. It is a very simple calculation. So here we can find that the value of m dot C. What is the value of m dot C here? Okay, 1.672 kilowatt per Kelvin is the equation. This is the unit for a CC. We are taking the m dot C value kilogram per second and 4.18 kilogram per kilojoule per kilogram degree Celsius, and we will get the particular unit as kilowatt per Kelvin. Yes. And CH equal to 1.347, right? 1.347 kilowatt per Kelvin. So what is the C minimum value here? C minimum, CH, right? CH is C minimum. C minimum and C max. The minimum value is 1.347 combined to 1.672. So we can use CH as C minimum and CC as C max. So in this equation, CH is there. So we can write C in the case of CH as C minimum. Okay, we can write the value, or we can write either we can substitute the value of CH here and C minimum value here. അങ്ങനെ apply ചെയ്യാം. അങ്ങനെ apply ചെയ്ത് കിട്ടും value of CH is 1.347. Okay, and value of C minimum is again 1.347. Okay, so we can use we can apply the particular value and cancel the value, or we can use this equation, put CH for C minimum, and C minimum get cancelled. Okay, so effectiveness equal to equal to C minimum by C minimum, C minimum by C minimum, TH1 minus TH2, TH1 minus TH2 divided by TH1 minus TC1. Okay, so the C minimum and C minimum or CH value is cancelled, and we can write the effectiveness value directly from here. That is TH1 minus TH2, 115 minus 40, 115 minus 40 divided by 115 minus 15. That is 0.75. The value of effectiveness is 0.75. The value of effectiveness we can find as 0.75. Okay. Effectiveness. Yes. So third question is to find the surface area, right? Third question is to find surface area. Surface area. So area by using NTU method, right? So surface area. What is the equation for surface area? I said that the only equation for using surface area is NTU equal to UA by C minimum. So the area equal to NTU into C minimum divided by U. NTU into C minimum divided by U is the only way to find out the value of area here. So you want to find the value of NTU here. NTU1. So I said that NTU can be found out by using an equation, or we can use the graph value. Okay. First, graph value. So please take your data book. Page number just after the particular F value. F value area value that page number 150. Okay, I will show you. I will show you in data book. Okay, the value. So for the last session, we have done a problem. Okay, we have committed a problem with using the correction factor F. We have find out the value of correction factor by using this graph. Okay, so after the particular correction graph, we can see a particular graph like this. That is effectiveness parallel flow. Okay, effectiveness parallel flow. Second, effectiveness counter flow. Third one, effectiveness 1 shell pass, 2 4 6 2 pass. Okay, and effectiveness 2 shell 4 8 12 2 pass. Effectiveness cross flow with both fluid unmixed. Effectiveness cross flow 1 fluid unmixed. Effectiveness cross flow both fluid unmixed. So this is the problem. This is a particular graph we are using in the case of NTU. Okay, NTU method to find the value of effectiveness, or we can find the value of effectiveness or NTU method. NTU the value of effectiveness in random graph. So please check the particular graph here. So in x-axis we can find the value of NTU. Okay, NTU is in x-axis. X-axis NTU. Okay, x-axis NTU is there, and y-axis effectiveness is there. NTU is in x-axis, effectiveness in y-axis. Okay, and the particular lines, the curved lines are the value of R here, R, C minimum by C max. R value is shown as a curved line. A curved line R value on R equal to C minimum by C max. So if the three terms are applying here, that is effectiveness, R value, and NTU value. Effectiveness, R value, and NTU value. So if we know the value of R and NTU, we can find the effectiveness value. Okay, and whether we know the value of R and effectiveness, we can find the NTU value. So R is a common. R is common. R and so additional to R, if we know the value of NTU, you can find the effectiveness value. And either other than R, if we have known the value of effectiveness, we can find the NTU value. Okay, that's the relation. Okay, so here we have to find the value of NTU, right? NTU. So NTU, for find out the value of NTU, we the known values are R value and effectiveness value. Okay, R value effectiveness value. So you may be in the thought that for last equation, the equation is like for particular counter flow equation NTU. So I NTU right? You area graph. So for finding the value of NTU, we want to know the value of effectiveness. Effectiveness തന്നിരിക്കണം, എന്നാൽ NTU കാണാൻ പറ്റുള്ളൂ, right? So if the value of R and effectiveness is known, we can find the value of NTU. So effectiveness is already calculated. Effectiveness is already calculated 0.75, right? So R value, we can calculate the R value C minimum by C max. C minimum is CH and C max is CC. So we can find the value of R and effectiveness, and by taking the value 0.75 on the value of effectiveness, right? 0.75. So here 0.75, here effectiveness, and particular curve. ഈ curveൽ നമുക്ക് വേണ്ട R value is C minimum by C max. So please find out the ratio of C minimum by C max, and നമുക്ക് വേണ്ട ഇത് ഏതാണ് curve എന്ന് നോക്കി വെക്കുക. So if particular equation 0.3 ആണ്, 0.35 ഒക്കെ ആണെങ്കിൽ നമുക്ക് ആ ഒരു റേഞ്ചിൽ intersect ചെയ്യുക, and after intersecting we can find the value of NTU here. What is the value of NTU? Okay, so like this we can find the value of NTU or effectiveness if R value is known. If R value and NTU is known, we can find effectiveness. If effectiveness and R value is known, we can find the NTU. Okay, so please calculate the value of NTU here. For finding the value of NTU, the values we want to know that effectiveness and R value. Okay, so R value, effectiveness is already calculated. So R value, we want to find the R value here. R value. So R equal to C minimum by C max. C minimum by C max. C minimum equal to 1.347. 1.347 is C minimum, and C max value is 1.672. 1.672. Find the ratio of C minimum by C max. Is 0.806. 0.806. 0.806. So from the graph, please write down from graph of counter flow effectiveness equation. From the graph page number, from the data book page number, please take your data book and please note that page number in your data book, page number 162, for effectiveness parallel flow graph. The NTU value for effectiveness 0.75 and R value 0.806. We can find the value 0.806 and 0.8 here. 0.8 is here. 0.8 is here. 0.8 is here. So the graph is flowing. Effectiveness 0.705. 0.705. Effectiveness value is 0.705. 0.705 means it is given in percentage. Okay, it is given in effectiveness is given in percentage here. So 0.705 means 70.5%. Okay, 0.70.5% is the 70.5%. So ഇവിടെ കണ്ടുപിടിക്കാം. സോ ഇവിടെ 70.5 എന്ന് പറയുമ്പോൾ ഇവിടെ വരും. സോ ഇത് പ്ലോട്ട് ചെയ്യുമ്പോൾ നമുക്ക് വേണ്ട തരത്തിലുള്ള ഗ്രാഫ് കിട്ടുന്നുണ്ടോ? 0.806 R value. Okay, 0.806 here. So the graph is flowing like this here. So we cannot find the value. കിട്ടുന്നുണ്ടോ കറക്റ്റ്? 2.3 കിട്ടുന്നുണ്ടോ? ഓക്കെ, കിട്ടുന്നുണ്ടെങ്കിൽ ശരി, അത് എഴുതുക. അങ്ങനെ കിട്ടുന്നില്ലെങ്കിൽ അതാണ് ഞാൻ പറയാൻ പോകുന്നത്. From the graph we can find, okay, from the graph the value is 2.3. right? NTU equal to 2.3. കിട്ടിയ വാല്യൂ ഇതാ. the text, the value is 2.3651. 3.365 minute ആയി എടുത്തിരിക്കുകയാണ്. Okay, so this is the value of NTU. We can find the value of NTU from the graph, or we can find the effectiveness on the graph. So ഇങ്ങനെ കിട്ടുന്നില്ലെങ്കിൽ, if we are not getting any particular value, if we want a particular close value, 2.3 എന്നുള്ളത് നമുക്ക് എടുക്കാൻ പറ്റുന്ന വാല്യൂ ആണ്. ഓക്കെ, ഇക്വേഷൻ എടുത്തിരിക്കുന്നത്. സോ ഹിയർ if you want accurate value, we can use that equation to find NTU. Other than using graph, we can also use an equation. That is, we know that effectiveness for a counter flow equation, that is 1 minus exponential of minus NTU into 1 minus R divided by 1 minus R exponential of minus NTU into 1 minus. This is the equation for a counter flow, right? E counter flow. So we can rearrange this particular equation. We can rearrange this particular equation in the form. Effectiveness E minus 1 divided by ER minus 1. ER minus 1. E minus 1 by ER minus 1. Step so we are skipping a step. M here writing E minus 1 by ER minus 1 equal to exponential of minus NTU into 1 minus R. Okay, here minus NTU into 1 minus R is there. So we can rearrange this equation. Please write down. We can rearrange this equation, and please mark it is important. That is, നമുക്ക് equation ഉപയോഗിച്ചും ചെയ്യാം. That is, ഈ counter flow. ഈ parallel ആണെങ്കിൽ parallel. For a counter flow, we can rearrange this equation as E minus 1 by ER minus 1. E is effectiveness. We know that 0.75 is the effectiveness value, and R is the C minimum by C max. C minimum by C max. So here we can calculate the value by using the only unknown value will be NT. NT very unknown value. So we can E is known, R is known. We can find the value of NTU from directly from here. Right, E minus 1 by ER minus 1 equal to exponential of minus NTU into 1 minus R. So E minus 1, that is 0.75 minus 1 divided by ER minus 1. 0.75 into C minimum by C max is 0.806 minus 1 equal to exponential of minus NTU into 1 minus 0.806. Okay. So find out the value of 1 minus 0.806 and I don't. And we will get that. We will get this equation. This will get an equation that 0.632 0.632 equal to 0.632 equal to exponential of minus NTU into minus NTU into 0.194. 0.194. Okay. So how we can find the, how we can cancel the particular exponential value? For cancelling exponential value, we will log കൊടുത്താൽ മതി അല്ലേ? Log കൊടുത്തു കഴിഞ്ഞാൽ, so if x equal to exponential of y, we can write this as log ln natural log x equal to y. Okay, log x equal to y, and we can convert that x equal to e raised to y in order to exponential is to y. So that is the equation. So we can convert by using this equation. Ln 0.632 equal to minus NTU into 0.194. 0.194. So we can find NTU as log this value. Find out the value of log this value divided by 0.194. We will get the value of NTU. That will be same as 2.3 something. 2.365. Our critical value on 2.65. Graph wrote the value. The value got by the calculation is 2.365. So it would have created like graph 2.3. So the same value will be get by using this equation or using the graph. Okay. So after finding the value of NTU, we can find the value of area. Area equal to NTU into C minimum divided by UA. NTU into C minimum divided by U. So U is given, NTU is given as 2.365 or 2.3. നിങ്ങൾ എഴുതിയിരിക്കുന്ന വാല്യൂ ഗ്രാഫ് നമുക്ക് 2.3 കറക്റ്റ് ആണ് കിട്ടുന്നെങ്കിൽ you can write 2.3. Okay, no obstruction. So 2.3 into C minimum. C minimum value kilowatt. C minimum value is in kilo. Okay, 2.3 value is in kilo. That is 1. CH value. That is okay. C minimum value is CH value. That is 1.347. 1.347 into 1.347 divided by U value. U value is 1450. 1450. Okay, 1450. 1450. So 1.50 value is given in watt, not in kilowatt. Not in kilowatt, is given in watt. So 1.347 is given in kilowatt. So ഏതും ഒന്ന് മാറ്റണം. So ഏതും ഒന്നല്ല, നമുക്ക് മീറ്ററിലെ വാല്യൂ ഏരിയ കിട്ടണമെങ്കിൽ, so if you want to get the value of in the unit of meter square, you want to convert the value of kilo into watt. So 1.347 10 raised to 3. Convert the value into 10 raised to 3. ഒന്ന് കിലോവാട്ടിലാണ് കിലോവാട്ടിലാണ്. സോ വാട്ടിലേക്ക് കിട്ടിയാണ് മീറ്റർ സ്ക്വയറിൽ കിട്ടുന്നത്. So we will get the value of area here. That is, the area will be 2.197 meter square. 2.197 meter square. Okay. 2.197 meter square. So this is the പ്രോബ്ലത്തിന്റെ ഒരു രൂപം മനസ്സിലാക്കുക. That is, this is the method to find out the something properties like area or NTU or effectiveness or anything in the case of NTU method is using these particular equations. That is, area can be only found out by using NTU, or NTU can be found out by using graph or particular equation. Okay. So for graph, if you want to find out the value of NTU, you must know the value of effectiveness and R. Okay. If you want to find the effectiveness using graph, you want to know the value of R and that NTU. So be familiar with the graph. Be familiar with the graph and be familiar with this equation and be familiar with the NTU method. Okay. So we can do more problems later in the class. So we can conclude now.